Yeah.
Alright guys, this is our second video on drawing tree diagrams and simulations. This is my assistant for the video. Do you want to say hi?
Hi.
Do you want to tell everybody what your name is?
Owen.
Owen. What do we see here? What do you see?
A clock.
It looks like a clock. Huh? What colors are on it?
Orange, purple, yellow, green, red.
That's it, huh? Okay, so in class we talked about drawing tree diagrams to show different outcomes of compound events, which is more than one event happening. And in this case, we're talking about spinning the spinner and flipping a coin. And so if I want to draw a tree diagram that shows all of the possible combinations of those two things, I would start, or I could start, what are you doing? I could start with the spinner. So I could get orange, red, green, yellow, or purple. Now, if I spun orange, I could get heads or tails with the coin. And that's true for any color that I would spin. I can always get heads or tails when I flip the coin.
Mine look like Mom, can you not see me in that picture right
No, I
there?
can't see you anymore. Where'd you go?
You see my hair?
I do see your hair.
Now do you see my face?
Mm-hmm.
Now do you don't, now can you not see me?
Now I can't see you at all. All right, so here's our tree diagram, and it shows all of our outcomes with the wheel and all of our outcomes with the coin. And if I were to make a list with that, well, I can't have you, you can't steal the pen because I'm writing with it. If I just went straight down my tree diagram, I'm going to start out with this first combination of orange with flipping heads. My list is just all of the combinations I could make. So I have orange with heads, oops, orange with tails, red with heads, red with tails, green with heads or tails, yellow with heads or tails. And sorry if you can hear the squeaking. That is my puppy. This is what happens when I don't have time to finish videos at school and I have to do it at home. And purple with heads or tails. So altogether we have 10 different outcomes that we could get with the spinner and the coin. So if I asked you, what's the probability of getting red and flipping tails? You would look at your list of outcomes and you would tell me, oh, well, on that whole list, there's only one outcome that is, red with tails. And so the probability is 1 out of 10. But if I just asked you, well, what's the probability of spinning blue? If I'm looking at my tree diagram, of spinning orange, I have 2 outcomes that involve spinning orange. I have orange with heads and orange with tails. And so the probability of spinning orange would be 2 out of 10. And the other piece that we're going to talk about on this video is what we're doing in class tomorrow and Friday, and that is simulations. We use a simulation to answer a real world question. So let me give you a couple samples. So something like this. If a cereal box contains 1 of 4 different colored pens as a prize, what is the probability of having to buy at least 5 boxes to get a blue pen? Now, we don't want to actually go and buy 5 boxes of cereal. And that would be one trial, and then we'd have to buy 5 more boxes to see what the probability is over and over of getting a blue pen after 5 boxes of cereal. So kind of similarly, here's another one. What is the chance that a cat will give birth to exactly 1 female from a litter of 3 kittens? We don't want to have to go find multiple litters of kittens to see how many of them happen to be female. That's not an efficient way to calculate probability, and so instead of doing all that, we do a simulation. So a simulation involves all of the manipulatives that we've been talking about so far. So dice, spinners, coins, cards, whatever. And it's up to you to decide, well, what is the best way to simulate this event? Now, this event that we're talking about is if a beagle has 4 puppies, what is the chance that they will all be female? And so I want a simulation, or I want a manipulative that's going to represent having male puppies, female puppies for this beagle. So if you have all the options there, there's some that are definitely better than others. So we'll start out with the coin. This would work wonderfully because there's 2 sides to the coin. One side could be male, one side could be female puppies. Same thing for this spinner. We have 4 equal sections, so we could call this male puppy, female puppy, female puppy. We have the same chance of getting male or female puppies. The problem with some of these other spinners, though, this one has 5 sections. There's not really a way that I could divide that up equally so that you're actually representing having a 50-50 chance of having male or female puppies. So that one wouldn't be the best choice. And then same thing with this one. There are 3 sections, and one is twice as large as the other. So if we want to think about a way that this one could work, we could say, well, this whole side would be female, and then these 2 would be male, and then they're representing the same amount of space on the spinner. So that one would work depending on how you look at it. Here we have numbers 0 through 9. We might want to say odd numbers, male, and evens,
Now what are you writing?
female. Do you see what I'm writing?
Yes.
What am I writing?
Female.
So, we know that the outcome of this event is this dog giving birth to either male or female puppies. And we have to have a model that's able to represent 2 equally likely outcomes, like we were just talking about with some of those manipulatives. And so a couple of good choices would be using a spinner, where we've labeled half of them male, half of them female. Using cards labeled 0 through 9, where even numbers represent female and odd represent male. And if you can hear that noise now, that is my daughter in the other room. Sorry if you're distracted. Okay, so when we're talking about a trial in this simulation, a trial would be, in this case, spinning a spinner 4 times or picking a card 4 times because this beagle had 4 puppies. And then a successful trial would be having 4 female puppies. We have 2 more slides to look at. So this would be another simulation. What is the chance that I will score 80% or higher if I guess on every question of a 5-item quiz? So as we're looking at this, we're using, let's say, a random number generator, or it could be dice, or it could be a card, or whatever. We're only using the numbers 0 through 1, or 0 and 1. So we could say that getting a 0 represents a wrong answer, and 1 represents right. This makes sense because if we're just guessing, we have an equal chance of getting them right or wrong. So an outcome in this simulation is getting an answer. And one trial in this simulation would be answering all 5 questions. 5 questions. A success in the performance trial would be getting that 80% or higher. Sorry, my daughter's upset. She's getting out of the bath. And the number of trials that I would want to perform would be as many, stop please, as many as possible. Because the more trials we do in general, the more likely we are to get an accurate count or an accurate probability estimate. I'm going to let you draw as soon as we're done with the video. Does that sound good?
Yeah.
Okay.
I'm gonna draw.
Okay, so the last thing I want to do is look at a relative frequency graph. So if we're talking about, in this case, spinning this wheel here that you see on the upper right that's labeled with colors. The graph is titled "The Number of Spins Needed to Land on Every Single Color Once." And there's 4 colors. There's yellow, blue, red, and green. And so this means that there's a 0.08, or an 8% of the time, it's going to take us exactly 4 spins. It looks like 12% of the time, it's going to take us exactly 5 spins. So you can answer a lot of types of questions about probability with a graph like this. Like I could say, what is the probability that it will take us fewer or less than 5 spins to hit all 4 colors? And if I'm looking at my graph, the relative frequency of 4 was 8%. And we can get questions that are more complicated than this too. I could say something like, what is the probability of it taking less than or equal to, let's say, 6 spins? So this includes these 3 sections, 4, 5, and 6. So I would say 16% plus 12%. So far I'm up to 28%. Plus 8% means there's a 36% chance that it will take fewer than or less than or equal to 6 spins, or at the most 6 spins. And this was just a quick overview of the last couple sections of Unit 4. Did you want to say goodbye?
Goodbye.